Assalamualaikum and good afternoon to Dr. Narshida binti Muhammad Ali and my fellow friends. We are from the first presentation group. Today, we will be presenting the topic of Group 1 or alkali metals. I'm sure as a chemistry student, you all must have learned about this group. So today, we will tell more details about the elements in this group and how these elements work. So first of all, without wasting our time, I'm going to introduce our group members. So first, Balkis binti Abu Johan is me, and Nurul Atika binti Ahmad Reza. The last one is Bainzatul Nusada binti Muhammad Hairi. Okay, first we're going to move to introduction. The group 1 elements in the periodic table, also known as the alkali metals. So Amir is asking, Doctor, why they are called as alkali metals? Then the doctor is answer, because when elements from group 1 react vigorously with water, it will produce an alkaline solution. Plus, for your information, in group 1, we have hydrogen, lithium, sodium, potassium, rubidium, calcium, and francium. All elements in this group is classed as alkali metals, but not hydrogen. Why? Hydrogen has 1 electron in its outermost shell, but it is not an alkali metal because it is not a metal but a gas at room temperature. So here we can see where is the group 1 is located. It is the leftmost column in periodic table. Okay. All the chemical elements in group 1 are very reactive. They must store under the oil to keep air and water away from them. The reactivity of group 1 elements will increase as you go down the group, because the atoms get larger as you go down the group. The outer electron get further from nucleus. And then the attraction between the nucleus and outer electron gets weaker as you go down the group. So the electron is more easily to lose. Okay, now I'm going to show you the scientific and common name, symbol, and the sources of these elements. So the first one is hydrogen. Hydrogen produced from a variety of primary fossil sources such as natural gas, heavy oil, water, and coal. The second one is lithium. Lithium is mined from different sources such as brine and hard rock. The next one is sodium. Sodium found in nature such as sodium chloride, sodium carbonate, and sodium borate. Okay, so we can see the halite and trona here, and this is the trona mining. Okay. For the next elements is potassium. Potassium comes from potash. Potash is an impure combination of potassium carbonate and potassium salt. There we can see the image of potassium with the coin that has diameter 19 mm. Okay, next is rubidium. Rubidium occurs in the minerals pollucite, carnallite, leucite, and lepidolite. It is recovered commercially from lepidolite as a byproduct of lithium extraction. And then we can see the image of carnallite. Okay, for the second last elements in group 1 is calcium. Calcium is found in the mineral pollucite and lepidolite. Most commercial production is as a byproduct of lithium production. And the last one is francium. Francium occurs naturally in uranium minerals as a result of actinium decay. Francium can be made artificially if thorium is bombarded with protons. Okay, so now we are going to see the history of alkali metals elements. So first alkali metal is lithium. In 1817, Johann August Watson analyzed it and deduced it contained a previously unknown metal which he called lithium. He realized this was a new alkali metal and a lighter version of sodium. He was a Swedish chemist who discovered the chemical element lithium in 1817 by isolating it as a salt. Okay, so we can see the image of Johann August Watson. Okay, next we see the history of natrium. Humphrey Davy exposed caustic soda, sodium hydroxide, to an electric current and obtained globules of sodium metal. So, Humphrey Davy is discovered for these natrium metals. We can see the image of Humphrey Davy. Okay, next is potassium, where we can see it's also Humphrey Davy is discovered this metal. So in 1797, the German chemist Martin Klaproth discovered potash in the minerals leucite and lepidolite. Then, in 1807, Humphrey Davy exposed moist potash to an electric current and observed the formation of metallic globules of a new metal, potassium. Okay, next we move to rubidium. Rubidium was discovered by two German chemists, Robert Bunsen and Gustav Kirchhoff, in 1891. With the use of spectroscope, they noticed that the sample of mineral lepidolite contained bright red spectral lines in its emission spectrum. Later on, they managed to separate a sample of rubidium metal. They decide on naming the metal rubidium, which originates from the Latin word rubidius, meaning dark red. This was because of the bright red line in the elements. Okay, next is cesium. Cesium also discovered by Robert Bunsen and Gustav Kirchhoff. In 1960, at Heidelberg, Germany, through the spectroscopic analysis of Durkheim mineral water, they examined mineral water from Durkheim and observed line in spectrum which they did not recognize, and that meant a new element was present. They produced around 7 grams of cesium chloride from these sources, but were unable to produce a sample of the new metal itself. And the credit for that goes to Carl Theodor Stadtberg at the University of Bonn, who obtained it by electrolysis of molten cesium cyanide. Okay, so there is the image of Gustav Kirchhoff and Robert Bunsen at the right. Okay, so for the last alkali metal is francium. Francium was finally discovered in 1939 by Marguerite Perret at the Curie Institute in Paris. She started this discovery in 1935 when she was 26 years old. She had purified a sample of actinium free of all its known radioactive impurities, and yet its radioactivity still indicated another element was present, and which she rightly deduced was the missing element is 87. The element names is from the country of its discovery, France. Okay, next I'm going to share tips about group 1. Okay, for the first tip is tips how to memorize group 1. Okay, for us that have a hectic semester now, I'm at these tips. Hai, lambat tol nak Khamis, Rabu cepat Friday. Okay, for the second tips, it is extra tips for atomic radius in periodic table, and we also can use it for group 1. Okay, we call it Bukit Bendera. We can see the shape of Bukit Bendera. For the first one is Bukit. When we go down any group in periodic table, atomic radius will be increased, and we can see the shape of Bukit is when we go down, the shape is getting more larger. And therefore, for the bendera, when moving from left to right across the period, atomic radius will be increased. And we can see the shape of bendera when we go from left to right, it is more smaller. Okay, so now I'm going to pass to my friend Maizatun Nusahada to explain about physical and chemical properties of elements in group 1.
I will explain about physical properties and chemical properties of group 1. General physical properties of group 1 elements. Alkali metals are good conductors of heat and electricity. Alkali metals have low melting and boiling point as compared to heavy metals such as copper and iron. This surface turns dull when exposed to air. Alkali metals also are grey solid with shiny slippery surface when freshly cut. Alkali metals are soft solid and can be easily cut. Alkali metals have low densities as compared to heavy metals such as iron and copper. This is physical properties of group 1 based on proton number, nucleon number, density, hardness, melting point, boiling point, atomic radius, electronegativity, and electron arrangement. Going down group 1, the atomic size of the atoms, the densities of the elements, the reactivity of the element increase, but the melting and boiling point decrease. Similar chemical properties. All alkali metals exhibit similar chemical properties. This is because all the atoms of alkali metals have one valence electrons. Alkali metals are very reactive. Although alkali metals exhibit similar chemical properties, they differ in reactivity. The reactivity of alkali metals increases when going down group 1. Chemical properties reaction. Reaction of alkali metal with water. Alkali metals react with water to produce a metal hydroxide solution and hydrogen gas. For example, lithium react with water will produce lithium hydroxide plus hydrogen. Next, reactions of alkali metals with oxygen. All the alkali metals react with oxygen gas when heat to produce white solid metal oxide. For example, potassium react with oxygen to produce potassium oxide. The white solid metal oxide form dissolve in water to produce metal hydroxide solution which are alkaline. For example, lithium oxide react with water to produce lithium hydroxide. Next, reactions of alkali metals with chlorine and bromine. All alkali metals react with chlorine gas when heat to produce white solid metal chlorides. For example, potassium react with chlorine to produce potassium chloride. Next, alkali metals react with bromine vapor when heat to produce white solid metal bromide. For example, potassium react with bromine to produce potassium bromide.
Sebentar tadi kita dah dengar pembentangan dari saudari Balkis dengan saudari Mazatul. Sekarang kita akan teruskan Group 1 Application of Elements. Next element in Group 1 is lithium. Lithium in rechargeable battery for mobile phones, laptop, digital cameras and electric vehicles. Lithium also used in heat-resistant glass and ceramics. Okay, next element is sodium. Sodium is used in production of titanium, sodamite, sodium cyanide, sodium peroxide, and sodium hydride. Okay, sodium used as an alloying metals. Sodium as a heat exchanger in some nuclear reactors. Okay, next element is potassium. Potassium used in manufacture in fertilizer. Potassium used in the manufacture of glasses. Okay, next element is rubidium. Rubidium is used as a component of photocell. Rubidium also used to remove traces of oxygen from vacuum tubes. Okay, boleh tengok sini gambar photocells. Okay, next element is calcium. Calcium metal vapor is used in atomic clocks which are so accurate that they are used as time standard. Saya akan tunjuk atomic clock, calcium atomic clock punya gambar. Next, the most common use for calcium compound is a drilling fluid. Okay, ni adalah calcium atomic clock. Boleh tengok sini. Okay, next is francium. There are no commercial application for francium due to its instability and rarity. Okay, next is Group 1 effects towards environment in 3 categories, which is plants, animals, and humans. First one, effect of elements towards surrounding category human. Sodium is used, good effects. Sodium is used to maintain fluid levels. Potassium acts as minerals that help regulate fluid balance, muscle contraction, and nerve signal. Lithium has anti-suicide effects. Lithium may reduce risk of dementia. Bad effect. Exposure to large amount of radioactive calcium can damage cells in your body from the radiation. Calcium causes hyperirritability and muscle spasm. Francium is radioactive. The particle that radioactive element give off can damage our bodies and can cause disease or cancer. Okay, next, effect elements toward surrounding category plant. Sodium, good effect. Sodium impair their ability to even uptake adequate moisture. Potassium increase root growth and improve drought resistance. Potassium aid in metabolism and synthesis of chlorophyll. Bad effect. Calcium is toxic to plants when absorbed at high concentration although this rarely occurs under normal environmental conditions. Okay, lithium reduces the plant growth by interrupting numerous psychological processes and altering metabolism in plant. Okay, good effect. Effect of element toward surrounding category animals. Good effect. Potassium activate enzyme. No. Okay. Effect of elements towards surrounding category animals. Good effect. Potassium activate enzyme that helps metabolize carbohydrate and protein. Potassium regulate neuromuscular activity along with calcium. Sodium maintaining osmotic pressure in the body as well as water regulation. Verified. Calcium induce ionizing and photochemical reaction and thereby incorporate into DNA molecules in animal causing genetic damage. Calcium causes primary skin and eye irritation, cutaneous sensitization, and oral acute toxicity. Okay, as a conclusion, so we conclude the elements in group 1 have many benefits to us, but the reactivity of group 1 elements increase as go down the group. So we have to handle it carefully because heavy metal react things more vigorously. Okay, boleh tengok sini reference group kami. Okay, terusnya adalah Q&A session.